experiences this scene. And first, I want to thanks the IEEE VR workshop chairs, Jason Jarrell, Joao, and others, Joaquin as well for helping us set all this up. And I hope all of you are going to enjoy the rest of the IEEE VR that has a lot of stuff going on this week. It is the premier VR conference, and we have great stuff going on. So I do want to uh, uh, thanks my organizers, uh, and this includes Faeza Borhani, which is my PhD student, and she's helping a lot here. She has a lot of patience with me. Thank you, Faeza. Susmit Shanigahri, which Tennessee Tech, um, which actually just texted me that they're having severe thunderstorms or they're having trouble with the internet. Espiros Mastorakis, University of Nebraska, Omaha, Nate Blanchard, Colorado State University, Rajiv Katka at Idaho National Laboratory, Daniel Safir at University of Colorado Boulder, Adam Williams, Colorado State University. He's not able to be here because he's in needed right now, and myself, Francisco Ortega, also at Colorado State University. I'll be thanking my keynotes and panelists and soon. Um, but the question is, why are we doing this workshop, right? Why is there a need to do this workshop? There's a few reasons, and it's not just because of COVID. I mean, collaborative environments, if we think about the future of augmented reality, headsets, glasses, and other devices as such, um, is going to become really important, and people are not always going to be in the same location, in a co-located location. So remote slash distributed collaborative environments are extremely important. uh, there's another reason, and as you know, notice some of the organizers are not 3D UI and VR people, and that's by design, because there's a lot of components that has to do that goes outside of our community of virtual reality, augmented reality, 3D user interfaces, and obviously you can think of networking as one of them, which is critical. But you have machine learning and also other areas which are more closer to us, like human robotic interaction and so forth. So we're trying to bring the community. The third reason is that this is an NSF planning grant that we told NSF, look, uh, we want to understand what the community needs, so we can then get software, hardware, equipment, general infrastructure to enable this research. And part of this workshop is that to understand what is it that we need, what is it that we understand. So you're gonna see some of that. There are, optionally, this is not required, but there's two surveys for this workshop. We're gonna be providing the links via the chat and also in the workshop Discord. Uh, and uh, the first two surveys deals with general question. The first survey, we have asked some of this before, but also questions about what is the knowledge you had before coming to the workshop. Well, survey two will be after the workshop, what do you think differently? And in general, it's like, how can we support your research to be successful? What are the pieces that we need, right? And obviously the large audience in this workshop today is the HCI VR AR community. Nevertheless, we do hope to have these workshops in the networking and the machine learning slash vision communities as well, uh, where my colleagues will be leading those. Um, Survey three, we're going to ask people as well that did not attend the workshop general knowledge. Now, we are going to give some good prizes for the workshop if you participate and enter your email, which is optional. And these are general questions. If you do survey one and two, assuming that you're in the workshop or you're watching this, you can get we'll do like a little raffle, and one prize of $250, two prizes of $100, four prizes of 50, and eight of $25 US dollars. And obviously, this will be paid with checks from the university, so they may take some taxes away. I apologize for that. And we'll see if we can get Amazon gift cards, but last time was a little problematic, so we have to buy it from our own money. We did a survey on this community a while back, and some people did get prizes. The prizes were a lot smaller. We didn't have the grant yet. Survey 3 is for people that didn't attend, and we will have one prize of $100 and four of 25. I do want to acknowledge NSF CNS 2016714, which is the one that's giving us opportunity to ask the questions that we want to ask, and also other complementary NSF, IAS 2037417, IAS 1948254. In we definitely, just like in the traditions, if any of you have attended Needed before, which is another workshop on this conference, we wanted to have demos, right, besides the papers. So papers come with demos. Obviously, it's a bit complicated in a virtual type of conference. Hopefully, this will be different at a later time in another conference. But we have 5 presentations, so 5 papers. I believe 6 papers were received, or 7, and 5 were accepted. We have 2 keynotes. We have great keynotes. We have 3 panelists, which also going to have a Q&A session. You can see here the breakdown of and we'll have 2 surveys to give out. This is linked. You don't have to do them. I will appreciate if you do them, and I'll be providing these via Zoom. Now, I do want to thank my keynotes, Dr. Jeff Burke, the first keynote, and Dr. Mark Billinghurst, the second keynote towards the end, the closing keynote. And the panelists is Dr. Anthony Steed, Paul Martin, and Dr. Greg White. And Anthony Steed, many of you know from the community. Paul Martin is very involved with HP Inc. in terms of VR. And Greg Wise from Cable Labs, which is a nonprofit organization that does networking research. And the idea with the panelists is that we'll have them do 20-minute presentations, and then we'll go in a Q&A so people can ask questions. How we're going to be able to ask questions, there are 3 methods. One of them is you can, when we open the session, you can raise your hand and you can ask the question. You can put it on the chat of the Zoom. Faisal will be monitoring those. And if you raise during the conference, which I do recommend because it's a great conference, you will have access to Discord. I will add the information how to get into the Discord, but they will check whether you raised or not. And you can also ask, there's a channel for the survey. This is also being streamed live, I believe, Twitch and YouTube, or it will be available on YouTube later and being recorded. And again, for any of the authors, panelists, or keynote, if you have a problem with this, let me know via the chat or to Faisal or myself, so we can address that and make sure that we comply with your wishes. We also have a website. We'll be posting the website in the chat. I'll be posting the surveys later as we go on the workshop. And so these are the instructions. I'll go ahead and post this. How do you connect to Discord? But you have to be registered in IEEE VR for Discord. I believe that if you register, there's also, I don't think you have to be registered, but there are some chat avatar sessions. The workshop is not involved in any of those, but if you register, go ahead and check all the other options you have. And I was hoping that Susme was here. I don't know if Spiro's here.
Yeah,
Spiros?
I'm here.
Spiros, would you like to introduce our keynote speaker? I think you'll do a much better job than I do because you know Jeff better.
Yeah, sure. So definitely it's my pleasure to introduce to you Jeff Burke. He's a professor in residence and vice chair of graduate studies at the UCLA Department of Theater. And he also co-directs the UCLA Center for Research in Engineering, Media, and Performance, REMAP, which is a joint effort between the UCLA School of Theater, Film and Television, and the Samueli School of Engineering. And again, it's our great pleasure to have Jeff with us today, and he's gonna be talking about XR Exile, distributed collaboration on extended. I just missed the title, Francisco. On extended reality production during the pandemic. Thank you, Jeff.
Thanks. Very happy to be here. I'm just
Thank
going to
you.
get
Yeah, let
set
me
up to
stop.
share
Let
my
me stop
screen.
sharing myself and
Okay, thanks again to the organizers for inviting me to participate in the workshop. I am going to go pretty quickly into the material to try to leave a chance for discussion at the end. So first, I'm going to give a bit of background on myself and the center, UCLA Remap, that I work at. I'm going to talk through 3 experimental production scenarios that we've gone through really since March of last year, focusing on augmented reality in the context of immersive theater, some remote virtual production, and a kind of transition into research on extended reality broadcast. And this is going to be production focused to try to have some application ideas floating around for the purposes of the workshop. But I will, at the end, try to go through a few takeaways for this particular workshop, some technical ideas I think that might be helpful or interesting for us to talk about. All right, so REMAP is a joint center between the School of Theater, Film, and Television and the School of Engineering. We do a lot of different experimental work looking at, in particular, real-time technologies and sensing in a variety of different artistic and community engagement contexts. Most of what I'm going to talk about today is work that's kind of roughly in the XR arena, working in real-time game engines that in a range of different entertainment applications that involves a mix of custom software development and production in parallel by a mix of students and staff from different disciplines. And one of the most important and sort of exciting things about working in these environments is that focus on really the topics of the workshop, that we tend to be thinking in distributed ways about participation, only recently remotely though. We're thinking inherently about interaction between both the kind of professional participants behind the scenes and with an end user audience, and increasingly on the collaboration that goes into authoring these types of systems. And I'm going to focus really on these research productions as a way into conversations about larger topics that I think are applicable in the more general arena of extended reality and interactive and distributed systems. In particular, one of my interests in doing productions around experimental technology is to look at how to support iterative and hands-on development, especially by folks like students who aren't necessarily going to be able to spend a lot of time digging into one particular technology in detail, and really instead are focusing on putting together an entire experience. All right. So to go into the first of the 3 arenas that I want to mention as far as our experimental production scenarios, I'll talk a bit about a particular augmented reality and immersive theater project that's about halfway through because of the pandemic. So this is a project called A Most Favored Nation that is a student-authored immersive theater experience around a concept that we had proposed about a year ago, to do a research production based on the streaming series The Man in the High Castle, with permission from Amazon Studios. So this is a collaborative AR piece, and by that I mean a sort of for end users, it's a multi-user AR experience within a larger theatrical production. I'll talk a bit about how it's developed, and kind of where the project is right now in terms of the experimentation and what we're learning from it. This is collaborative work by many, many people, and that's part of the point of talking about it here. Large number of students, intersection with staff, and then overlap with our production team and partners. And so just to quickly introduce the concept of the story, in the television series and in the original book by Philip K. Dick, the Axis powers have won World War II in an alternative timeline, but they have access to, or there's a kind of rising resistance based on access to an original timeline or a set of timelines that are close to our own. And we wanted to look at that experience in augmented reality. We went through a multi-quarter course process to develop both the story, the strategy for augmented reality that I'll talk about a little bit, the virtual environment that's overlaid on a physical set. And then we're able, even in the COVID context, to finish out some of the physical set construction and experiment with the AR overlay. I'm not going to have time to get into the story, but I can share the slides later if folks want to get more detail on the individual storyline. The important thing is that there are really two parallel timelines of interaction. One that's in the physical world, you're kind of seeing that in the middle of this concept image, and one that is seen through an AR device that exists in story, carried by, we're hoping, up to 50 audience members that are using devices provided by the production to view the alternative timeline and look at the different histories, really. And so this is just a quick test on stage that gives you a sense of the type of mockups that we're doing that involve a physical set, the panels in the background, the ladder, the person working, those are all in the IRL world. And then the photos and images are generated, of course, in AR. To play a little bit of a kind of closer to finished product sample here that shows video being used as a proxy for the volumetric capture that's intended to be done when we can resume production. And you're seeing a little bit of the alignment of the real world and the physical world as we kind of pan around the space here that's using some custom multi-fiducial alignment code that we're using to allow props in the physical world to act as the fiducials that we're using to align the augmented reality components. A couple of just things to mention while we're looking at this video. We are, in this context, running a multiplayer Unreal game on iPhone devices with then a large number of people participating as operators or controllers, in this case remotely. So some folks that are managing when does the video play back, when does the scene transition, what are other elements that get introduced dynamically based on, you can't see any physical actors right now because of COVID, but based on the action of audiences and actors in the space. And then certainly also to manage the state of the participants. And we just remove the AR in the image. You can see a bit of the physical space here. So this is to give you just a sense of that experience. So in this augmented reality and immersive theater mixture, we are really interested in interaction on all the different levels that I mentioned before, and in co-presence in physical space and virtual space. But because of the pandemic, we found ourselves in a situation where we were also exploring in parallel in other projects that the school was doing, a fully remote virtual production that involved a large number of off-campus student actors being kind of incepted into a 3D virtual world. And this was a chance for us to explore a more general sort of trajectory that we're interested in that hasn't really made it into the mainstream of consideration, in particular in live performance in our department and often more broadly, which is that if this is familiar to this audience, if you think about the old model for media production on the left, that's still in many ways what's in people's minds in production processes. We start with a concept, we go through pre-production, we move into production, head to post-production, and then distribute, and often distribute in 2D, even if we're working in more sort of exciting and interesting ways in real-time 3D, even in the middle. And our interest in these productions is to shift towards the real-time model on the right that's closer to the types of things we're doing in augmented reality, but also allows us to draw in remote participants that may have really limited resources in terms of capture during the pandemic. And so just to hit on a couple of key ideas about that type of real-time model, again, pretty familiar, I think, to you here, is that using real-time technology allows us to iterate and hopefully with some additional upfront investment in the production lowers the risk as we start to experiment. We are authoring code and media in parallel. We can see a little bit more of how the interactions emerge. And certainly then there are other benefits as well that I'm mentioning here. And so as we shifted in March to remote work, we tried very quickly to spin up an effort that took the types of kind of 2.5D video experimentation that we were doing to get through testing in the Man in the High Castle project into experiments that would allow our student actors who were stuck remotely and all the production folks to start experimenting in creation for virtual environments. And this was a pivot applying the same engine, the same plugins, the same sort of approaches, but trying to get them in a fully remote situation. And so I'm going to play just a little bit of that kind of quick work that was done last summer as an example here. And so what we were asking students to do was design virtual environments, incept 2D video from remote participants into it,
Our experience
and
puts the audience
then
in
look
the
at
place
the
of what we
performance
are,
process
that's like
that, or
wandering
look at
through
the
this big dinner
performances
scene with
that
3
resulted.
parts,
So
where
again, this
simultaneous
is
action
in
is happening
Unreal
at all
with
times.
some tools to remove video from Zoom. There's a kind
We
of
were
more
interested in
extensive set of
exploring this idea
examples as
of
we
like
go here. I'm just
how
showing you
this medium
the
could
types
lend
of
to
things that they were
simultaneous
working on.
action and
Probably
what would be
pretty
the agency that
familiar
the
to this group.
audience could have.
All right. And in that shift, we started to see some possibilities for creating a full-length production and encourage the department to kind of experiment not just with the final format, but also the workflows that might be possible in this distributed environment, and look at the way of working for designers, instructors, actors that were creating these kind of live to tape style experiences. So a larger experiment that followed that was the creation of a custom shared virtual environment for a theater production of Last Days of Judas Iscariot that was done by in our School of Theater, Film, and Television. This involved 16 remote actors, at least an equal number of remote crew that were operating in parallel, the same kind of 2.5D way of working with live video that you saw before, and a workflow that I'll explain a little bit later as far as some of the technical issues. And so a lot of what we were learning was less about the technical mechanics, although there was a lot of that, but it was what it meant for people to be in a space that was not really conducive to performance, these small boxes in people's apartments and homes that were connected into a shared virtual environment, and some of the limitations of feeling like you were part of participating in that environment were the takeaways for us. I'll play just a bit of what some of the rehearsal process looks like in some sample footage from one of the designers. And so, pretty sort of easy to imagine 3D game world that has within it individual 2D actors that are being pulled as WebRTC streams into a studio environment, then into Unreal as a network video, and then again, sort of externally cued and live timed transitions from moment to moment. That allowed us to explore this kind of intersection of telling stories in a game-like sense with and animations in real time with actors that were performing live. So this allowed for sort of a live to tape methodology while still exploring real-time 3D. We can talk a bit about what we learned from that. The general transition for us has been to kind of, I think now, consider what does it mean if we shift the client experience? So, and think about extended reality broadcast that is using 3D engines for rendering at the client endpoint. So something that exists in web VR, but certainly doesn't exist in the way that we think about production right now, at least even in some of these research projects and virtual production processes that are using real-time 3D to generate the 2D imagery at the end. So before I discuss that, I wanted to kind of break down here some of the components that were being used and make a few more general points about them. So I thought about originally drawing this in a block diagram format, But in the end, there are so many different connections across these components that I think it's better just to lay out what the individual components were and discuss how they related to the collaboration. So I mentioned already, we're going to kind of go from left to right. I mentioned already the use of fairly standard remote setups for actors. In order to scale to 16 actors, we could provide only limited equipment and generally required them to use a web browser to capture a WebRTC stream from their remote setup, and then provided a kind of return loop of feedback of the final composite image from Unreal to them on their browser side, which had a pretty significant limitation. And I think this is the appropriate place to mention, which is that we were showing them an audience point of view, but not really their point of view within the virtual world. And so one of the things that I think we would be thinking about more carefully, and if we had the resources and the right type of client-side software, we would have even at that time wanted to return to them something closer to their point of view in the shared virtual environment, even though they were working in this 2D green screen context, rather than just a master production view. But they had a return view of the production. Sometimes they were in frame and sometimes they were out of frame. And each of those individual WebRTC streams were then fed into Unreal Engine with a custom environment and some custom plugins that we've used over the course of the projects that I mentioned, that became sort of the central compositing environment. One of the most significant shifts that was made here that's not mentioned on the slide explicitly is that we started to work in editor in Unreal. And this was a kind of transformative way of thinking and required some changes to the software that we had been using to integrate video and animations and other components, and help the students to move that were working on the production to move very quickly from looking at the final product to manipulating the environment. And it seems, pretty straightforward, but it's not always the way that we might think about a runtime for a live performance working. And so going forward, I think a lot of our focus will be on things where the editing environment and the production environment converge, and the focus of collaboration is on the ability to, for certain participants, to manipulate that environment live, whether we do that with an existing editor or new. That seems fundamental to the types of collaborations that we're looking at. Of course, we used, probably not unexpectedly, Zoom and a tool called Zoom OSC, which allows some network control of the Zoom environment as the place for all of the participants to meet in a reliable 2D video conferencing setup while they were working in Unreal. I think just because of the limitations of the custom software in Unreal that we were developing in parallel. And then there were a few other components that I think are helpful for this group, maybe some familiar and maybe some not as familiar. We used QLab, which is a standard theatrical tool for sending triggered messages or playing back media at certain times, a manually controlled system usually, to trigger shifts in the environment that might, shifts in the virtual environment, and use those network messages to make transitions into certain animation sequences, changes in dynamic lighting and environmental effects, manipulation of video, and so on. And that way of working allowed us to actually provide multiple QLab instances. Some used for sound, some used for lighting, some used for environmental effects and animation, and actually pretty easily distribute that control of different elements of the live experience into across different remote participants. In parallel with this, we were using TeamSpeak for real-time audio collaboration to have a secondary audio channel. So if instructor and director and actors were in Zoom, everybody else was in TeamSpeak, giving us a parallel audio channel, actually a set of parallel audio channels to coordinate on. And then we were using Slack for asynchronous communication with the actors, which I mentioned here not for technical reasons, but because the kind of mix of capabilities was important for us. So at the same time that experimentation was happening, though, of course, we were working on stage. And I'll show a little bit of an example of this in a moment. when we get into the takeaways for the workshop. But that work on stage encouraged us to think about how do we start converging the remote production and the physical onstage production. So what you're looking at on the left here is a kind of studio mock-up setup that's evolved on stage in one of our theaters at UCLA, LED wall at the back, a set of monitors at the front that allow access to the usually the 2D views of the remote participants, but also the 3D previews, and the ability to step into either green screen, camera tracked virtual production environment, or more recently, live volumetric capture and other things that are being experimented with. So as we go through this process now, we're thinking about really the intersection between the types of production experimentation that I'm describing and the real world and the physical set. So there's a lot of experimentation in related arenas that are happening right now, from virtual production or XR production to large scale experimentation that's happening in game engines like Fortnite, native in those existing 3D engines. So our interest and some of the research background that we're bringing to the discussion of takeaways for the workshop is the following: starting to look now at the intersection between remote collaboration and IRL production in the context of extended reality, in all the different forms that term can mean. Shifts to remote 3D clients, something that's more akin to a concert in Fortnite than it is to a broadcast delivery from within a virtual production stage. The idea that if we are moving into kind of IRL world, that augmented reality's current kind of preoccupation with the point of view of the end user is not necessarily the only way for us to gather information on what's going on in a large environment. I'll talk about that in a little bit. And then also some fundamental changes to the way that we think about media that's inspired by the type of experiments that I mentioned before. In particular, the idea of data-centric access directly to media using something like named data networking, and then the organizational challenges as well. So let me switch gears a little bit now to talking about the kind of takeaways from this type of experimentation, and slow down a bit to discuss some of the technical issues that we think would be intriguing here. So I'm going to go through these takeaways in a way that I'm going to kind of work through each keyword of the workshop title in reverse order, starting with experience. And so one of the sort of missing pieces and interesting areas of research is in how semantic scene descriptions would allow us to connect IRL or real world and virtual elements, but we don't see them in most of the tools that are available. And certainly we don't have the ways, at least in commercial tools, to wire together some type of semantic description of the physical world with a semantic description of matching or complementary elements in the virtual world. And I'll talk a little bit more about that in just a second. I think there are, one of the sort of intriguing developments in computer vision for us is the idea of scene analysis that can result in some type of network or scene graph description of the elements of a real world scene with semantic tags that allow them to be interpreted. I think we'd like in each of these experiences to be able to move away from manipulating elements purely based on where they lie in a 2D capture, a 3D reconstruction, or some other coordinate system, and towards thinking about and manipulating them in semantics that might parallel scene graph or world graph descriptions in a game engine. We don't have those, and so there's a lot of time working on the coordination of IRL and virtual coordinates. And then the second is actually related to the first, which is this notion that in these projects, and I think in a variety of other applications, we are looking for elements and working with elements that bridge the real and fictional ontologies. In our case, the world of the story and the world just going to open the chat and make sure I see questions if they come up. And those are, let me give a quick kind of shift to an example of that and try to explain where some of the opportunity is. So I mentioned this project in AR based on The Man in the High Castle that we've been working on. And in the story of The Man in the High Castle, in the Philip K. Dick book, there's a novel that tells a story of an alternative timeline where the Allies win the war, among others. And in the Amazon series, there are newsreels that show the characters that are stuck or grew up in this alternative timeline where World War II ended differently, an alternative. And in this way, there's a sort of parallel between the form of the story and an element in it that's fundamental to the narrative. And so in our case, in our particular further adaptation of the work, the augmented reality exists in that same way. In the story, there is a device that's a modification to a state-issued personal television that's used for propaganda that is modified to become this device that allows a kind of televisual view into an alternative timeline. And thus the AR exists within the story. And so we have multiple overlapping ontologies that we're dealing with where we want to refer to a real world object or an actual actor or an actual audience member. And then we have a parallel ontology, at least one, where they exist in the fiction in potentially different relationships to each other. And so as we think about, well, what does it mean to have a experience-focused system? Experiences are often based on kind of this notion of a fiction or a metaphor or a story for pedagogical purposes, for simulation purposes. We see the same thing in some cyber learning research that we had done where kids participate in simulation systems where they play a bee or are a flower in a pollination scenario. And there are very few tools in these collaborative systems for managing the fact that people exist really in multiple layers and in multiple ontologies and relationships. So when I mentioned the notion of the connection from the physical world, a physical scene graph, to a virtual scene graph or a virtual semantic description of an environment, that's one element. The other is that that objects kind of play multiple roles and have multiple relationships. And there aren't a lot of tools for working with that sort of thing programmatically. And so when this is a screen capture from one of the rehearsal experiments in this AR piece, and we want to be able to conceptualize the person that's holding the device, both inside and outside of the story, and manage their kind of physical reality as an audience member and their fictional participation within this simulation, this sort of large multi-user simulation. And so one of the suggested takeaways for discussion here is the kind of opportunity to provide that kind of customized and layered set of multiple ontologies. All right, so kind of working up the chain, I'm going to show a little bit more of an example from that AR project and talk a bit about the way of working. What I wanted to push on a bit was the notion of the relevance of latency. And, there's a important and continued focus on lower latency in interactive systems, in VR in particular, to address physiological issues, responsiveness issues. And of course, these things are critical in those experiences at some baseline level. But as we worked through production in the pandemic, of course, everyone was suddenly very tolerant of latency because we were stuck in Zoom. Nothing was quite wired up the way that we expected it to be. And what instead became the key sort of focus of latency and frustration in the process was build and compile steps for content and interaction. So these are artifacts of most tools that exist commercially for this type of work that even in real-time environments, there's a fairly substantial compile step or a limited ability to edit while existing in one of these environments without an awful lot of work. And that was one of the kind of fundamental things that we felt like what needed some technical innovation and at some point want to spend more time on. These may these relate generally to the notion of multi-user authoring in space and time. And I think we found it quite straightforward to author in space and to have collaborative multi-user editing of a 3D space, and a lot less straightforward to think about collaborative editing in time. And we'll get to that a bit in more detail in thinking through interaction and opportunities in interactivity, in support for interactivity in these collaborative experiences. Let me show a little bit of video
a lot of our
from
testing has been sort of this on-stage
AR
portion, so that's why what we're
experience
talking about sounds
two of
like
the
an
former
immersive
students
theater
explaining
production. And then as we go into what we're doing in the next fall, it's sort of now thinking about how we deliver it.
It's super cool.
That's great too.
Derica, you want to take the video? Yeah, go.
All right, so I'm going
Mira, do you want to explain a little bit?
this and
So we were really fortunate to work with our actors by sending them green screens. And since we couldn't do ball cap, we did two-sided green screen planes. So
okay. So this is showing off some of the 2.5D experimentation that was being done in AR. But what I want to point out here are the different views that you're seeing. Of course, the zoom boxes that have been cut out and placed at the bottom. But on the left, a real-time capture from a mobile device that was the audience view. And then in the upper right, me, since I was one of the few people that could be on campus, walking around the stage environment and being filmed just from a fixed point camera. And then on the bottom right, the operator view from Berlin in VR. And so these are all sort of different perspectives into the simulation / production. The